We're going to start a new feature today. It's the pause and try feature. If I keep these videos short, like I'm going to try and do, I still want you to have practice while we're doing the tasks. So when you see pause and try, well, do exactly what it says. So we're factoring trinomials when a equals 1. And there's some basics that you need to know before we get started here. One of those basics is the concept that we're using, which is area model multiplication. Basically, if you have two binomials being multiplied together, what's a way to multiply them? And though there's many of them, one of the options is to take your x plus 3 and list it on the left-hand side of a rectangle, and x minus 9 the other way. And then you multiply the sides. X times x is x squared. X times negative 9 is negative 9x. X times 3 is 3x. And negative 9 times 3 is negative 27. And then essentially you just combine like terms and you get x squared, and then this is minus 6x, and then minus 27. And this is a model of the way in which to multiply. Now, probably a good idea to have you try this. So go ahead and pause and try right now. And let's move on. Now, when dealing with division or dealing with factoring, sometimes you're going to find yourself having to determine one side of a triangle, which is really just a division problem. What I'm going to show here is how you can use long division to go ahead and accomplish this goal. You may want to pause for a sec. Sorry, you don't want to pause. I'm going to pause the video and do the long division and then come back and show you what it looks like. I got x minus 1, so the concept here is that x minus 1 is the missing side length in this rectangle. Once again, good time for you to pause and try your own. And the missing side length would be x plus 4. So that's what happens when you have a polynomial and one side but not both. What happens when you have a polynomial with neither side? So that's really where the area model is going to work. And how that's going to work is going to look like this. So here's what we have. I've taken the polynomial, I've turned it into an area model style problem with some parts already filled in, nothing on the outside's filled in yet, but here we go. If you're seeing how we did this, I took the first term and put it in the upper left-hand corner, and then what will happen is, what times what equals x squared? Well, x times x equals x squared. And then we have a 15. I take my last term and I put it in the bottom right-hand corner, and this is where the experimentation comes in. Because there's a couple different options for what we multiply together to get 15. I could put a 1 times 15, or I could put a 3 times a 5, or I could put a 5 times a 3, or heck, I could even go with decimals, though I don't want to do that because that's not how this is going to work. So we're going to do a little experimenting, and the concept behind the experimenting is I want these two terms to add or subtract together to give you 8x. So my combinations that I could work with would be 1 and 15, because 1 times 15 is 15, or a 3 and 5, because 3 times 5 is 15. And the order in which I write these doesn't really matter at this point. What I do know is that 3 and 5 will make 8, and 1 and 15 will not. So 3 and 5 must be my choices. So what I'm going to do is put a, let's see, fill in my gaps. I'm going to put a 3 with an x here, and x times 3 is 3x. And then I'm going to find myself putting a 5x down here, and x times blank is 5x, so this has to be a 5. And now, x squared, 8x, and 15 is what I started with. So x plus 5, and I'm putting plus because it's positive, and x plus 3, and I have myself an answer. So I draw, I experiment, I answer. Let's watch that again, all right? So first term goes in the upper left, last term goes in the bottom right, and we're going to do some experimenting. I know that I want these two pieces to add together to become negative 2. So here's my thinking. First, the easy stuff. X times x is x squared, so that's going to be part of my answer, and I could even go ahead and put that the whole way down here. The second part is going to be a little harder. I need 35. I need two numbers that multiply together to give 35, like 1 and 35, or 2, 3, 4, 5 times 7. Those are good combinations, and those are my only combinations. And I need them to combine together to make a 2. And there's no way 1 and 35 are going to add or subtract to give me 2, but 5 and 7 could do it. But now I have to put them I need to arrange them correctly. I need the 7 to be negative and the 5 to be positive in order to get a negative 2 out of there. So I'm going to go negative 7x and positive 5x. I know I don't write the plus, but I do that to keep things straight. And here we go. X times what is negative 7x, so negative 7. And x times what is positive 5x, so positive 5. And there's my answer. I can double check. X squared negative 2x and negative 35 is what I started with. So x minus 7 and x plus 5. Seems like a good time for you to try your own. So here's the third one in the series. Pause and try. And here's what you should get. I rewrote my problem, drew it. I experimented. I filled in my gaps. In this case, I needed both the 2 and the 4 to be negative because that's the only way I was going to get negative 6. And negative 2 times negative 4 is positive 8. So I'm still following my rules. And here's my answer, a little scribble because I put the wrong variable in there. But that's how you do it. Let's try 2 more. And with those 2 more to try, here's what you'll find. The first one worked out really well. I got x minus 8 and x minus 3. By the way, if you wrote these x minus 3, x minus 8, it's the same thing. That's the commutative property, so we're okay there. And on the second one, kind of a tricky question. I found myself in a situation where I needed to multiply these 2 numbers together, whatever this number and this number would be, to get positive 2. Well, to get positive, they have to be the same sign. So either I was going to take positive 1 times positive 2, which would work, but wouldn't add up to give me negative 1x, or I was going to have negative 1 and negative 2, which once again would work on this piece, but wouldn't give me negative 1x. Since this was my only pair that I could use, and neither one of the options worked, this is prime, which means it's a polynomial that doesn't factor, just like we have numbers like 37 and 41 and 7 that don't factor. Those are prime also. So polynomials can be prime just like numbers can.